Dear students, into this another topic of the size reduction. Today I am going to discuss about the theories of the size reduction. As you are knowing that size reduction is one of the unit operations and it depends upon the number of characteristics of the particles. Here into this theories we are going to discuss the various laws which are affecting the size reduction process. Now here the various laws of the size reduction basically highlights what are the energy requirement for the particle size reduction. As in the previous videos of the factors affecting the size reduction, I have highlighted the various factors which are affecting these unit operations. So here the energy which is required to reduce the size of the particle is basically inversely proportional to the size raised to the sum of the power. So if you want to write a common equation for what is the energy required for the particle size reduction, it is written like a dE upon dt is equal to negative C over d raised to n, where E is highlighted the amount of energy which is required to produce a size reduction change or the particle size change. Capital D is the size of the unit mass, while the C and N are the constant. If we are going for the integration of this equation, then we can get a simple equation like E is equal to C into log E di upon dn raised to n. Here, if we are taking the different values of the n, then we are going to get the different three theories which highlight the different energy requirement. As for example, if you are going for the case n is equal to 1 or then n is equal to 1.5 and then is equal to value 2, then it will highlight the three different theory like Higgs theory, Bond's theory and the Rittinger's theory. Now let's try to understand in the detail what are the differences of this all the three theories are there. First start with the Higgs theory. Higgs theory again highlight into which the energy requirement is directly proportional to the ratio of the change in the size. What is the meaning of this one? In this consider we are taking the ratios of the initial particle size to the final particle size, and basically this theory is used for the complex of the larger particles. So when we are going to going for the size reduction of the larger particle by the mechanism of compression, we are preferring this particular theory. The another theory which is highlighted that is called as the Bond's theory. Here in this case, the energy which is required for the particle size is directly proportional to the crack length which is produced. So here in this case, we are taking the values of the di and the dn, that is the 1 over the square root. And this bond series is basically useful when we are going for the particle size reduction of the rough particles, and it is basically used for the comparing the efficiency of the various size reduction processes. The third theory which is highlighting that is called Rittinger's theory. Rittinger's theory here consider the two-dimensional parameter, that is the surface area. So here we are going to take into the consideration the surface area. As you are knowing the surface area, it is multiplication of the length to the width. So here we are taking that the difference between the newer surface area which is produced to the initial surface area, and this Rittinger's theory is basically useful for the brittle materials which are undergoing the size reduction process. So these three are the main theory which are highlighting the various size reduction process will be there.